Hello, this video is going to be about how to turn off a lit bulb. In the last video, we were wondering how to light a bulb with a battery and a wire. Now we're going to see if we can turn off a bulb that is already lit. So here is one of the ways that we can get a light bulb. A lit bulb? How about a lit bulb using a battery, a bulb, and one wire? And I mentioned briefly in the previous video that one of the ways we can make it not work is by putting something between the bulb and the battery or somewhere else in the circuit that is a non-conductor. So if I put something here that is a non-conductor like wood or glass, then if we try to trace the path of conductors, we go, and we're done. Let's try to trace the path of conductors going the other way. We take this wire, we go in to the bulb, and we go out, and we stop there. There's no complete path. So one way to turn off a lit bulb is to stick a non-conductor into the complete path. I mean, you can also turn off a lit bulb by opening the circuit at any point, but that's kind of not very interesting. So that's one way. Put a non-conductor in. The other way is to add a wire in a certain place. So if we have this lit bulb and we add a second wire that does this, right like that, turns out the bulb won't light. And that's because the battery now offers the charges that it's pushing around two paths. So if you think about it, the battery's job is to push charge. It wants to push charge out that way and pull charges in that way. So it's a conveyor belt. It's like, I want things to go around. And so when there's no wire here, it says, okay, I'm going to push things up into the bulb, it's going to go out the bulb, and then come back. Nice, happy circuit. We're all good. But when I add the second wire, what I've got available now is I can push things through the bulb, or I can push charges through this wire. Well, if you had to make a guess, would you say that it was easier or harder to push charge through a single wire than it is through a bulb plus a wire? You probably say it's harder to go through the bulb plus a wire, right? Because not only are there two things, but wire's pretty easy. If you imagine trying to push charge through a single wire, that's pretty straightforward. So yeah, what's happening here is that there are two paths for the charges to take, and the charges go, okay, I've got a difficult path, I've got a really easy path. And here's our phrase, path of least resistance. The majority of the charges are going to take this very easy path. There's usually still some that go here, but it's such a small amount that you can't see the bulb light at all. The bulb will turn off. And this wire right here, we call it a short. That's a shorting wire. This is a short circuit. And it's a short circuit because we have a bulb that is lit, but then we add a wire and it shorts out the bulb. The bulb doesn't light up anymore. And anytime you have a wire that's going to go from one end of the battery to the other with nothing else in it, that's a shorting wire. We could also get this to turn off the bulb if we went from here to not the top of the battery, but the tip of the bulb. Because then it could go, well, I could go through the bulb and then through this wire, or I could just go bloop, right on over. And so again, that's going to be the path of least resistance. So almost all of the charges are going to be flowing, and they're going at a pretty good clip there. There's a lot of them flowing per second, whereas there's a few going here, but not very many are going to go. So here is a short circuit, and here is this is what we call an open circuit because it doesn't have a complete path of conductors. So we could also have an open circuit with that. But again, that's the boring one. That's easy to turn off a light. And so think about, when we're thinking about these things, I want you to think about tracing the paths of conductors. Start with one end of the battery and see about tracing paths of conductors and see where they lead you. See what information you actually get from them. All right. So there is short circuits and open circuits. Good job.